Okay, fine. Then we are starting. So, a very good morning to the August audience and eminent guest. We are now going to start the technical session for the third day of this online ISCA project phase 2 faculty development program on application of artificial intelligence and machine learning in security. This is being organized by the Department of Computer Science and Engineering, Maulana Abul Kalam Azad University of Technology, West Bengal, and sponsored by the Department of Electronics and Information Technology, Government of India, under the Information Security Education and Awareness Project Phase 2. Today, we are privileged to have with us Dr. Firdaus Ahmed Barbia, Associate Professor at the Indian Institute of Information Technology, Guwahati. Sir, on behalf of the Department of Computer Science and Engineering, Maulana Abul Kalam Azad University of Technology, West Bengal, we welcome you to this event. Moving right along, it is now our pleasure to introduce our eminent speaker, Dr. Barbia. Dr. Firdaus Ahmed Barbia received his PhD as well as MTech degree from Indian Institute of Technology, Guwahati, and B degree from Jorhat Engineering College under Dibrugarh University, all in computer science and engineering. He is an associate professor at the Indian Institute of Information Technology, Guwahati, in the Department of Computer Science and Engineering. He is also the Associate Dean of Research and Development of IIIT Guwahati. His research interests include cloud computing, computer and network security, Internet of Things, computer vision, etc. He has several research projects funded by both government and corporate funding agencies. He is also active in consultancy services for various government departments and corporate. He has published many research papers in several international journals and conferences of repute. He has substantial experience in the software product industry, and he is now translating it into broader avenues of academics and research. He is a member of IEEE and FCM. May I now request you, sir, to enlighten us with your speech on role of machine learning in information security and detection of fake news a case study. Sir.
Thank you very much for the introduction. It's my pleasure to speak a few words in this August forum of information security, education, and awareness, specifically at Maulana Abul Kalam Azad University. It's been my, I believe, fourth or fifth deliberation in the university, and it's always been a very enriching experience. I could learn a lot from the participants and other panelists in my earlier sessions, and I'm sure my experience today will also get enlightened. At the outset, I would like to request all attendees to make the session as interactive as possible. Please ask as many questions as you want, and no questions are bad. One-way deliberation, I believe, it's kind of a stale thing. It's very easy to say a few things in one-way deliberation, but it's very difficult to digest. So let us be as much as possible, interactive. And my agenda today has three parts basically. The first part I will talk about a little bit of current security situation, and what are the challenges that the security community across the world is facing, and specifically in India. And then I will try to introduce machine learning in cybersecurity. The typical, some of the very well-established techniques, or some of the highly used techniques that are popular in machine learning. And then the third part will be to take you through a case study. So let me share my presentation. Please let me know when you can see it. Okay. So I hope my screen is visible to everybody.
Yes, sir, it's visible.
Okay. All right. Let me pull up my PPT. As I mentioned, my agenda is simple. These 3 points. Let's look at what networked world means today. In 1980s, when first internet, when internet became started becoming popular, it used to be a few universities and research organizations connected, point to point, and they used to exchange messages which were not that critical in nature, and it was very sparsely populated. But if we look at, I tried to pull through a graphical representation of current internet, thanks to Niti Aayog. So one of their pictorial representation. See, it's very densely populated, and with the advent of newer technologies like machine to machine, I mean IoT, and thanks to the cheaper smartphones, number of devices that are connected to internet is increasing dramatically. Some of the figures, if we look at, speed of microprocessor chips doubles almost every 12 to 18 months. The storage, or rather the storage density, I mean the amount of data that can be stored in a single disk, almost doubles every 12 months. Bandwidth, the technology for bandwidth is also doubling almost every 12 months. And the price keeps on dropping, making the technology affordable and pervasive. I remember those days when we used to purchase a simple, maybe couple of inches in size display. A smartphone with couple of inches of size of display in many thousand rupees, and that was not very long. For it's like 15 years back, it used to be, the scenario used to be like that, and you hardly can transmit data. Those days, GPRS, or those who have used, it used to struggle. But now, what we are doing is basically streaming content at 4K even on a mobile device. The camera resolution increasing every day by day, and thereby the contents are becoming huge in size. The amount of texts that are getting generated, be in the form of emails, be in the form of logs, be in the form of social media posts, are humongous in size. And all of them can possibly contain bad element, that is security threat. Let's look at the internet in India in 2020. We have close to 730 million internet users, and 75% of the new user from rural areas. Those who are in social media for quite some time, say let's say like last 10, 15 years, and if you look at your friend list, and if you see recently who are sending you friend request, of course new acquaintance will send you, but you will see it's more of non-urban people are joining the social media, or they're joining the internet thanks to 4G revolution and data war, so a few big events that has happened, right? And the new user, they consume data in vernacular languages in there, thanks to the non-urban class, now a lot of content is generated using Indian languages. I'm not saying the urban people doesn't do that, but urban people are a little fluent English speakers, so they can actually express in English. Most of their work or their communication, they are proficient in English, but when the village fox comes in, their preferred mechanism of communicating is mother tongue. And if we look at the mobile video growth, it's 83% CAGR. It's a year-to-year basis, which is huge. We have 175 million online shoppers. Again, and these are all estimated bill value. I'm sure these figures can be much, much higher. That means these people are doing transaction, on the e-commerce portals. 70% of these transactions are happening via mobile. Okay, and it is predicted that, of course, the pandemic has given a big, if not full stop, but a big semicolon on the travel and tourism. But then the 50% of the travel transaction became already online. So with that, the now amount of challenge that you can see, there will be challenges in the form of identity theft. There will be challenges in the form of phishing. There will be challenge in the form of targeted attacks. There is challenge for women fox, specifically cyberbullying, and of course not only women fox, but it's all genders are almost affected by cyberbullying, hate speech. Then society at large at risk, uh, by some element like who spread fake news, etc. One might wonder that what can be, as such, what can be a very can it be a very large impact of fake news on the society? If you look at it, like a fake news can possibly, and it has already happened, can lead to communal strife. It can lead to regional strife, and specifically in a society in India where we have multiple cultures, multiple languages, where like every 100 kilometer our identity changes, our language changes. So all that has very serious consequences, a very serious challenge on our society and as a country. So keeping in view of that, Government of India has identified a lot of measures, and ISEA, the sponsoring agency for this webinar, is also one such initiative. And all of us has, specifically those who are in academics, be whether we are students uh, or faculty members or researchers, we have a lot of responsibility and also a lot of scope to work in these areas. Let's look at a little bit of bookish definition, like what the cyberspace is all about. Dr. Shantanu, forgive me, I do not know what other speakers spoke. If I'm overlapping anything, please let me know. I will skip through.
No, that portion has not been described. You can continue.
Sure, thank you very much. So that's one good part of webinars are like, I need not travel and I can do it at ease, and you also need not travel. Logistics is not required. The not so good part is that I cannot see all of you, and I cannot feel what you are understanding and what you are not, and also I do not know what has already been discussed and what is not. So feel free to stop me at any time and say that, okay, this is what I need to repeat, or this is what already has been done and I can skip, or you already know it. So cyberspace is nothing but a connected internet ecosystem. That means it is everything which are connected to internet. We call it as a cyberspace. And the trends which are exposing critical infrastructures to increased risk, they are like interconnectedness of sectors. Today, we earlier, maybe 5 years or 10 years back, a decade back, we used to talk about connected, enterprises or web-enabled organization, let's say core banking solution. But now it is interconnected. The bank is connected to other organization. For example, bank is connected to e-commerce, or bank through different applications. The banking interface, specifically the Veeam API, is exposed, and a lot of others, so credit cards. Um, if we look at other day-to-day transactions, there are heavy interconnection among these elements, and there is high proliferation of exposure points. If I remember what used to happen in say early 2000, 2004, 5, I used to go to office in the morning, turn on my laptop or desktop, used to work the whole day. Mostly I was in front of the computer, and in the evening I shut it down and went back home. Right now, what is happening? I am always connected. My laptop is in sleep mode, but it is never off. I have multiple connectivity. So while driving back home, I'm also connected through my mobility device, that is mobile phone. And that is one device, like all of us are connected 24/7 by 365. So the exposure point is, these days is much, much higher. Earlier, there was another challenge that was there for the bad guys, was the bandwidth. In India, or specifically, eastern part of India, we didn't have good bandwidth. But thanks to this 4G or other technologies, we now have better bandwidth. I do not call it as best, but still better, and which is better for the bad guys as well. So for them also, it is easy to break through our systems. And then concentration of assets. There are certain things which were never connected to internet, but now they are. For example, power grid. And we have just seen in 2 days back, of course, that may not be a cyber attack, but failure of power grid can lead to catastrophe. We have seen that in Bombay. The train stops, lighting, of course, is not available. The whole transportation mechanism, uh, you know, takes a hit. The electric vehicles will not work. Um, then offices will not work. Lifts are not available. Um, it can lead to potential disasters like situation. Think about confined offices which totally runs on air conditioner, and there are plenty of them in almost every city. And if power is not available for 2-3 days, possibly people will have to desert those offices. Okay, so I was wondering like what happened to Bombay Stock Exchange, but thankfully they had backup power and they were operating on backup power. Right. So this concentration of assets which are connected to internet now, that is posing different threats. So if you look at, like, I tried to list a few areas again from the NITI websites, and I took screenshots, so that's why resolutions are not that great. So I sincerely acknowledge NITI Aayog on this. So if we think about anything, food or agriculture, energy, IT, postal and shipping, bank and finance, communication, name any sector, it has a IT footprint or a cyber footprint. And then these days, it is not only the cyber security which is important, but there is a new terminology called cyber policing. Every conventional crimes also has a cyber footprint. These days, it is very difficult to imagine that a crime will happen which doesn't have a digital footprint. That means no phone call will be made, no message will be sent, right? So this is highly unlikely. And there are challenges around that as well. So if we talk about critical manufacturing, emergency services, water, electricity, every possible areas, we have issues or we have challenges. So now a question arises like, why don't we remove all these vulnerabilities altogether? But we have proofs available that these vulnerabilities cannot be removed. The imagination, I mean, for example, developing software actually is not a pure science, but it's an art. And there are multiple ways of doing that. There are better ways of doing it. There are not so good ways of doing it. And whatever today is considered as secure might not be secure in another context or tomorrow. The way uh, increase in the processing power, memory, etc., is advantageous for us, is also advantageous for the bad guys. They also can compromise you faster. We talked about innumerable entry points to the internet. And then assigning attribution is another challenge. It's very easy in internet to forge identity. One can pose as an attacker, naming any country, any identity. I'm sure all of you know that this popular newspaper reports that Chinese hackers, Pakistani hackers, such and such hackers compromised such and such site and such things. It may not be the case also. You never know. It may be a guy sitting next to you, or it may be somebody sitting in Gurgaon, Bombay, or anywhere else. And somebody who is actually doing something nasty, I don't think he will expose his own address or own details so easily, because he knows that someone can actually target him or target that organization back. Nevertheless, I'm not denying that it can originate in any country, but attribution is very, very challenging task. So, and then who all are involved in these challenges? It can be nation states. That means a whole state can be, say, for example, our adversary nations, we all know who are all they are. They might, or non-state actor, there might be somebody in any country where they are doing it without the authorization of the country, or it can be any individual. So it's such a level playing field that a school-going kid can pose a threat to a nuclear installation in a country. So that is why it's complete asymmetric. Doesn't matter whether you have missiles or um, aircraft, fighter aircrafts of which generation, you can still be attacked in the cyber world. Let's quickly look at like how things evolved. In 1980s, cybersecurity meant viruses. Converse to it was the antivirus firewall. In 2000, early 2000, it used to be worms. So we talked about intrusion detection system and prevention. In late 2000, we talked about botnets, and we talked about application aware firewall, SIM, etc. But in today's world, what we are talking about is something called APT, or advanced persistent threat. We are talking about insider attacks. We are talking about, and what is the way we are looking at it is to analyze the network flow. Because in APTs, there are many APTs where the attack is launched by legitimate command on the client's machine. That means no foreign binary is required. No foreign executable is required. What it does is, for example, it uses the zip algorithm or the compression algorithm of your machine, and just think about it like they convert your important files and they zip it and put a password to it you do not have access to. And ransomware, they basically encrypt it and blackmail you. So we are moving towards a much more complex future, or even the present is pretty complex in cybersecurity scenario. Similarly, see the weapon across the time, if we look at how things has evolved. Now we are not only talking about like threats, but we are talking about cyber espionage, cyber warfare, etc. Over this period of time from 1980s to till today, the weapon, the availability of weapon to launch cyber attacks has dramatically become more available. And at the same time, the attackers' knowledge that is required to launch such attack became very low. That means one need not be a cyber pro or very knowledgeable in cybersecurity to launch such attacks, because such tools are so easily available, and one can buy as low as $5. Okay, think about it. Credit cards are available for sale. I mean, credit card number which works actually are available for sale at as low as $1. Okay, people's identity, emails, address, phone numbers in millions of are available for sale in less than $10. Okay, so and all that are happening in dark web, where the traditional way of looking at internet doesn't work. For example, if you do a Google search, dark web pages mostly doesn't pop up. And how that happens, that's a different topic. um, I cannot talk it because in the interest of time I cannot talk about it today, but it's maybe some other day, some other time. Okay, so that's the evolution of cyber threat. And what is the Indian scenario? The India ranks third in terms of the highest number of internet users. Again, one of the reason is our large population base. And the number has grown sixfold between 2012 to 2017. Imagine in 5 years, it has increased 6 times, and with a compound annual growth of about 44%. Considering these numbers, do we have enough cybersecurity professionals? Have we increased our cybersecurity professionals to sixfold? And whether we have, increased our skill, diversified our, area of work that way, is a big question. India secures a spot among top 10 spam sending countries in the world. Okay, we are not less. We are sending one of the top 10 countries who sends a lot of spam. I mean, we are along with US. India also ranked among top 5 countries to be affected by cybercrime. And the report recently is being published by Symantec Corporation. Symantec is a big security organizations, best known for their security solutions in the form of antivirus, endpoint security, etc., etc. If we look at a few cases, July 2016, we have seen the Union Bank of India issue, where an amount at the tune of $171 million was at stake, thanks to some alert, employees of the bank that helped bank to recover almost. They lost some money, but almost everything could be recovered. But you see, that is a very, very large threat. $171 million, and that too from a nationalized bank of maybe Union Bank. I'm sure it is in the list of top 10 banks. If we look at next attack, it is in May 2017, that was WannaCry ransomware. It actually wreaked havoc in the states like Andhra Pradesh, West Bengal, etc. And what it does, it actually blackmailed by encrypting the files on target machine, and then asking for ransom, and that too to be deposited in the form of Bitcoin. And I heard a few people who actually paid also, but never got back anything. I mean, they didn't get the key also. Then in May 2017, there was a huge data theft at Zomato. About 17 million users' details were stolen by so-called ethical hacker. Okay. In June 2017, there were Paytm ransomware, so on and so forth. If I talk about like even 7-8 days back, also there was a huge attack by one of the fileless malware. That means a malware which doesn't have a file actually. I mean, which doesn't reside in a file. How that happens? Again, you will have to do a little bit of research around it. That's again a separate talk. So in 2017, why I'm referring 17, because a lot of such data is available from Niti Aayog. India specific data is available. Otherwise, it's difficult to find India specific data. Almost 50% of the organizations has been reportedly affected in 2017. That means 1 in every 2 organization has been affected by cybersecurity threats. And what were they? Phishing was on the top, followed by malware, spear phishing, denial of service, ransomware, etc. And if you look at the frequency, kind of 998 incidents with 471 with confirmed data disclosures. And that was in one single year. There were the top 3 patterns that were there was denial of service, web application attack, payment card scheming, etc. So if I keep on speaking on this, it will take time. So in the interest of time, I will move forward. So who are all behind all these breaches? 75% are outsider as expected, but many of these outsider can be insider as well, because attribution, as I said, attribution is very difficult. It's difficult to say who they are. An inside element actually can use a proxy, a server hosted elsewhere, maybe somewhere in US, somewhere in China, and launch the attack. And 25% case is which involves internal actors. That is even dangerous. Our own internal people were involved. 18% were conducted by state affiliated actors. That means it was by some organized, well-oiled machinery, sponsored by some country. 3% featured multiple parties. That means not only one organization, but multiple organizations, they combined their effort. So there is again another dangerous pattern. Okay. 2% had some pattern, and 51% involved in organized organized criminal groups. What tactics do they use? 60%, 2% use breaches, 51% use malware, etc. 43% social attacks like social engineering, 81% is like hacking related breaches. See some chat. Okay. So I will go to that. So the request has been to talk about AI and ML. Maybe another couple of slides. Maybe I can skip through. So who are the victims? There are different types of victims. Who are the common? So let's talk about role of machine learning. In cybersecurity, the role of machine learning is relatively new. Earlier, the paradigms which were mainly there for detection mechanism, one of the paradigm uses some machine learning, which is known as, in intrusion detection system, there used to be something called anomaly detection, which used some machine learning. Otherwise, mostly, even today also, most of the detection mechanisms are based on signatures. But then that has its own challenges. We will talk about it. So that's my outline in this area. Like, what is artificial intelligence? Um, Before that, Shantanu, I have 2 hours, right?
Yes, yes.
Yes, sir.
Okay, okay, perfect. Um, of course, I'm sure many people have talked about it. What is artificial intelligence? I won't go into details about it. Um, I'll talk
We
about.
can take much more than that if required.
No problem. Thank you very much.
We can take more.
No problem. So I mean, old-fashioned. I'll talk about a little bit. What is the traditional or old-fashioned artificial intelligence? I'll talk about machine learning. I'll talk about deep learning, and I will talk about implication of AI in privacy and application of machine learning in security, specifically intrusion detection, websites, and email classifications, and then followed by a case study of what we have done. We have worked on multiple areas, but I'll talk about today is one of the recent work which you have done. That is about fake news detection. Okay, so artificial intelligence is nothing new. The initial enthusiasm started in 50s, and if you look at the enthusiasm, I'll just quote an unquote New York Times. What it expected that the embryo of an electronic computer that, when they mean the Navy, expect will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. That was the expectation in 1950s. Of course, the realization came in early 70s or late 60s that AI is very hard, and the fall of the perceptron in 1969 with the book called Perceptrons. So then came the development of multi-layer perceptrons, called mid 80s. I understand these terminologies are slightly difficult, those who are not pure machine learning people, but nevertheless consider it is just as a history. Then came the realization that machine learning programs are very hard to train, which was a realization in early 90s. And in mid 90s, there appeared something called support vector machine. And in 2010s, we got something in the form of deep learning, and which made things much more doable, which were earlier not possible. We'll look at it. So the research that used to happen like 50, 60 years back in around artificial intelligence, it all started with Alan Turing. We all know that it started with Alan Turing's some influential papers. And it used to talk about knowledge representation, planning and scheduling, grammars and language rules, search optimization, theorem proving, game playing, rule-based system for vision and perception. These are the areas, and those who of us studied artificial intelligence in 90s, all of us know these were the syllabus. But what artificial intelligence means today is entirely different. Nevertheless, many results were obtained in those days. For example, efficient search methods, using heuristics, pruning technique, then new language paradigms which are related to AI like Lisp, Prolog. But the challenge remained that the approaches were not flexible at all. And it has been figured out that the real world is very, very complex to be formalized using artificial intelligence. And it was impossible to hand code all possible combinations. Then came the machine learning, where we use a lot of data, which we call as data sets, to learn rules. I'm not sure in this audience how many of you are familiar with machine learning. So I assumed that everybody is everybody has some familiarity, but you may not be a professional. I'm not expecting everybody to be an expert in machine learning. So I will touch upon a few basics of machine learning, and if you maybe those who are seasoned programmer, you might find it a kiddish example. So please bear with me in everyone's interest. Dr. Shantanu, I hope that is fine, or otherwise I can skip through the basics.
Yes, sir, it is fine.
Okay, fair enough. So we use data sets to learn, and the technique is as similar as like how a child learns. If you have observed a kid, how they learn, basically when they touch a hot object, then they know that there's not a very pleasant feeling. So next time they avoid it. Basically, they learn from experiencing it. They learn, from prior experience. So the data actually has the details of prior experience. So we can use data to learn, what is, let's say, if I want to classify what is good, what is bad, what is safe, what is unsafe. So we can use data sets. I will show you an example of data set in next few slides. Each instance of the data set is normally defined by something called a set of attributes. And there are two paradigms. One is called supervised learning, another is called unsupervised learning. And there is a third paradigm as well, which is called semi-supervised learning, which has become very popular in last a few years. I'm sure many of you know what is supervised learning and what is unsupervised learning. In case of supervised learning, every instance has a label, or the data that is there, the meaning of the data or the metadata is known. That means description of the data is known. And the system learns to map from these attributes. In unsupervised learning, the system aggregates events which are related, which are kind of similar, and learns to attribute these labels. Okay. Now the challenge of supervised learning is that where do you get so much of label data? See, in case of information security scenario, what a label data means, that a data which is given, and it is also said that it is an attack or not. Attack, not attack. So that way, who will give you? There might be some data available from some research institute, academia, but that may not be sufficiently large, or that may not have sufficient variety. But then in case of unsupervised learning, the challenge is different. You have so much of data, but then you don't know what the data is, and you need to figure out the data is. So there is a technique which is in between called semi-supervised learning, where a small amount of labeled data is available and a large chunk of unlabeled data is there. That means from your large data repository, you label some portion of the data. Let's say you have a database of network events, and some of you, let's say 5% of that data, you have labeled it whether they were attacks or not attacks. And using that, can you infer or can you learn from the large amount of data which is not labeled? So that's semi-supervised learning. That's a simple data set. Let's talk about it's a network traffic. It has country of origin and country of destination. It has a packet length. It has a payload length. The protocol port, that is TCP port, source IP, destination IP, and then there is a label. So Germany, Portugal, Germany, France, Portugal, and there is one case which looks a little different from the other cases, and it is labeled as intrusion. That means it has been found that origin was Russia and destination as the US, and these were the details, and it was detected as intrusion. Okay, so now given this data, can we make a system which can say that which one is intrusion and which one is not? I mean, a new, so a new member comes in this data set, a new row comes in this data set. Can we tell whether that is an attack or a normal traffic? Now, if we have only these few data, it might be very difficult to say. But if we have very large amount of data, let's say 1 million data points, and there were like about 100,000, that is 1 lakh data, which is traffic between Russia and USA, out of which 80% were this source IP, and many of them were detected as intrusion. So in such case, using our human mind, we can easily conclude that whenever I see another traffic which is originating in Russia, destination in US, something similar to this packet length, or maybe this same packet length, maybe similar payload, same port, same source IP, destination IP may be varying, we can easily say that this is an intrusion. Okay, so that's what the basis of machine learning is. Now, how do we do it with a computer? And how do we do, actually mathematically model it? That's what machine learning talks about. Now, that was level data. Now here, see, there are some pictorial representation of certain balls. There are red balls, there are black balls, and yellow balls. Now, if we consider red and black are two categories, let's say we say that red are good and black are not good, and there are two more balls which are yellow in color, can we classify them into one of these, whether they belong to red or black? That is what is unsupervised learning. Now, can anybody think about a technique of figuring out which class they belong to? I mean, whether they belong to red or black, the two yellow balls. And how do we determine it? I'm sure those of us who have visited Sabji Mandi, we know the Sabji sellers, they always sort the tomato. Some are in green color, some are in red color, and some are in orange color. Okay, and they put different price tag on it. Similarly, potato based on size, color, etc. Right? So how do they actually identify, or how do they classify? What is their basis? Anyone? I would be happy, if some of you interact. I mean, any idea is fine. I mean, you won't have to be a machine learning or a cybersecurity expert to talk about this. This can be.
Sir, they differentiate between the darker ones and the lighter ones. Means
right. So think about think about from computer science point of view. So how will you distinguish between darker and lighter?
So it will be more towards the black side, and I mean for a black color side. So if we put in RGB respect, then all will be like 0, and for whites all will be 1.
So you have answered almost correctly. The color has a value, so we can try to figure out the distance. From computer science point of view, we can figure out the distance between the color, right? if black has some, let's say 256 is the value, and yellow has say 128 is the value, and green has like 220 as the value. So we know that green and black are closer to each other, right?
Yes.
So that's how they match. So one approach, not sure, to do that is by calculating distance between them. So there are different techniques of machine learning. For me, humanly, it's not feasible. Even if I talk for a month also, it won't be. I won't be able to cover these techniques because these are full codes, or rather multiple codes actually these days. But there are various techniques like regression, distance-based learning, probabilistic learning like naive-bayes, Bayesian network, then decision trees, neural network, support vector machine. I'm sure some of you have heard all these terminologies. Clustering, association rule, boosting and bagging, etc., etc. I mean, and this is just fast a few, the kiddish a few, and every 2-3 months, or rather every month, I see new techniques, and I'm having a tough time to keep myself at least updated in this area. Okay, so every alternate, week, you will see new papers are coming up, new tools are coming up, new versions are coming up, etc. So in case of distance-based learning, what we can do is we can find out the nearest possible neighbor. For this yellow, we can see that the nearest possible is this black. So for this yellow, nearest possible is this black. Maybe we conclude these are black. Okay. Again, in case of machine learning, please note that you cannot guarantee or you cannot vouch for a result that I have classified and it will be the perfect classification. It may not happen. But if you do not use machine learning, then the question comes like, why do you use machine learning at all? If you do not use machine learning, you do not have any other way or any other mechanism to deal with such situation. Okay. All right. Now let's talk about an example of decision tree for finding out a security attack. You see, we take the root of the tree as origin. We take Germany, China, different countries as origin. If the origin is Germany, we next check port. If the port is 465, we say, let me check, there is some message in the chat.
Hello. Yes, sir.
No, sir just went pause. Sir's video went to pause.
I think there is a network connection problem.
Sir, Faraday sir has lost the connection.
Yeah, let us wait. Let us wait for him to join again.
Let's wait. He is disconnected. He is trying to join. Hello. Just wait. He has got disconnected. He is trying to join. He will join.
Am I audible to everybody now?
Yes, yes.
Yes, yes, please.
Sorry, I got disconnected.
No problem.
Yeah,
That's
I
not
know the
your
reason
problem.
why, because this is a peak time and everybody in the office started live streaming because everybody is taking classes, and the bandwidth starts starving, and these days the NCAN bandwidth is pretty much full because every institute is working remotely. Okay, so fair enough. Let me pull my PPT back and share my screen. So I think here I was that looking at the origin, maybe a specific origin like China, maybe we know, okay, it's a security attack. Uh, Maybe because my organization doesn't have any client in China, so I do not, or any employee in China, so I do not expect my, let's say, ERP system or my financial management system to have a traffic originated from China. For example, some local banks in India doesn't have a Chinese customer, so why on earth somebody from China will try to log in using internet banking? Okay, so right, and maybe if you look at some other destination, based on destination, whether it is Germany or US, so you can actually form a tree-like structure and take some decision, which is known as decision tree. So the decision tree is based on input and previous knowledge. For example, it can isolate. You see, we can isolate almost all red dots or red balls, and from the yellow and black balls. But of course, you see, there is one red ball which is outside, and there is one black which is inside. So these are accuracy problem. A machine learning algorithm or a machine learning technique has this inherent property. It can miss certain things and it can falsely detect something. Okay, we'll see to that a little later. So the algorithms for searching the right tree has already been developed, and you can actually read from elsewhere how the decision tree is being made, and maybe that's a good point to start with using AI in security. Of late, we have seen multi-layer network. I'm sorry, I forgot to introduce what is perceptron, but there is something called perceptron in machine learning, where you can have, so in a multi-layer network you can have input layer, and input layer has some, I mean, in between, so there is an output layer, and in between input and output layer there are hidden layers on which you do, or you try to build some model based on the existing data what you have, the patterns what you have, what we discussed just now, that based out of based on those experiences or data set, you can try to create an output layer. That's about multi-layer network. Now, what is so different about AI today? I would say in two words, it is deep learning. And why deep learning was feasible? Again, I cannot introduce all this technology, but there's something called neural network. Some of you might be familiar, and if you are not familiar, there are so many tutorials available over the internet. You can just refer to that. The neural network, again, it had hidden layers, and multiple layers were always there. And if the number of layers are more than certain layers, we call it as a deep learning. So it has those layers. So why we didn't talk about deep learning say 10 years back or 15 years back? The reason was the bottleneck was the computers. Now with high performance computers, and again thanks to the GPU cards, which were originally designed for display, to have a better display. And again, that has a story. So as we all know, those who have studied a little bit of computer graphics, the display involves a lot of array processing, right? Because the pixel values are stored in multi-dimensional arrays, etc. And that is why for they were very good processor. For those number crunching problem. But then later on, people thought that why not we use this display processor for computational task also, and that gave companies like NVIDIA a very big boost. Okay, so NVIDIA used to be like when we were a student, it used to be a display company, a display card manufacturing company. And now what they claim, they are an AI company. They say that we are an artificial intelligence company. So what has happened? That the normal processor frequency has increased, capability has increased, multi-core, multi-processor, and at the same time, advancement in GPU. So we've got very high performance computers. What is possible today with a mid-sized desktop or a PC was not possibly feasible with like 10 servers, say a decade back. At the same time, there is availability of very large data sets. Due to enormous amount of transactions that are happening on the internet, we have large sets of data. And lots of accumulated knowledge about AI. The AI was there for, as I mentioned, like 5 decades. So we have accumulated a lot of knowledge around AI. There were a lot of trained people. And what it delivered, that is ability to work with real world data. It handles vision, natural language, high dimensional data. So when I was a master student, most of us didn't believe much in these AI areas. I remember I did a course on something called mobile robotics, which involved a lot of artificial intelligence. And that was not our first choice. NLP, at that time, everybody could not clearly tell the scope of NLP beyond translation, transliteration, and recognition, etc. But today, NLP is part and parcel of modern day computation, specifically with so much of text that are getting generated in social media. Right? Similarly, high dimensional data, and the impact is economically very relevant. Now, how it is relevant? If you have seen that if you search for certain product on any portal, any website, or even let's say Google, and next time you open an application, let's say Facebook or any other, you visit any other site, what kind of ads do you start seeing? Just search about that LG refrigerator 190 liter, and then what happens? Possibly you start seeing ads about what you have searched. You have not searched in Facebook, right? So how Facebook came to know about it? This is all because these companies are doing heavy, NLP computation, and they are taking data points from your computer as well. And how that happens, again, it's a very complex, dynamics. one simple thing I can tell you, that while um, giving privilege, or while installing any application, you see these days it asks for a lot of privilege, and some of the privilege I'll tell you what is SMS and email. They want to read SMS, they want to um, read email. Okay, if you see, if you are working, if you have a monthly salary, or if you, even if you are a student and your parents are sending money in your account, during the days when salary is credited, you will see a lot more ads, and ads around consumer goods and merchandise, etc. The reason being that these big bosses, e-commerce bosses, they know that you have already been credited by this artificial intelligence became weaponized. It became kind of a weapon, and data mining is being applied in device, video and photography data, satellite data, etc. So ensuring privacy is very, very difficult. It's not easy, and it might become impossible in near future. I'm finding personally, even if I, with an experience of about 2 decades of information security, personally I'm finding it's very difficult to preserve my privacy. And every day I find new loopholes through which people are breaching my privacy. Okay, and you cannot deny that I will not remain connected. You have to remain connected. You have to do transaction on the internet, but at the same time, your privacy is at stake. And why it has been considered as crucial. Now, in case of new threats identification, artificial intelligence can play a big role. What is the reason? That if it is a new attack or new threats, building signature. Now, how to build? So let's talk a little bit about this antivirus and anti-malware, etc. How they work? That when a malware is found, the researcher or the engineers at different uh, security agencies, they look at the binary, they try to find out what is unique about the binary, and they try to create a pattern about that binary. Now, whenever they, next time they see any binary, or rather they add whatever this template they have created to their database, what we download as updates of antivirus. Okay. Now they require certain time, and then even if they add it, there are techniques called metamorphs. What an attacker can do is they can simply change certain things within the binary. For example, those who have a little bit of assembly knowledge, you will understand that they can add some jump instruction. Okay, jump into instruction is like in C language we have a go to statement. It's a go to statement. Let's say go to line number 10, and line number 10 says a is equal to a plus 1, and again says a is equal to a minus 1, and then again says that go to line number 11. So which ideally doesn't have any impact on the executable's nature, but then being the binary has changed, now the detection will fail. One of the very highly used detection, signature is called MD5 hash. Basically, you create a hash value out of those binaries. So hash value, the moment you change a single bit or byte in it, hash value will be different. And at the same time, the attacker knows what the antivirus companies has done, because that is public in nature. Okay, so AI can speed up the process of noticing such attacks. If something is going anomalous, if something is going not in the way it is supposed to be. And there are many startups in this area which works. There are Indian startups as well. There are a few startups from Portugal who are famous in working in this area. So let's talk about a little bit of applications of machine learning in security. One of the early one is, as I mentioned in the beginning, is intrusion detection. What is intrusion now? Anybody who tries to, or any program which tries to illegitimately or without your knowledge try to access any computational resources, it is called intrusion. Some of the examples are these days, intrusions are of many different sorts, but some of the very relevant ones these days are malicious JavaScripts and other scripts. Remember, when we access any website or portal, it has some JavaScripts. Now, these JavaScripts from the trusted source, they are not supposed to do anything nasty. JavaScripts actually executes on the client. That means it executes on my computer. Okay, which is kind of a not so safe thing. Now, if there can be a nasty JavaScripts, it can try to steal something from my computer using those scripts. Then it can execute program. There can be malicious non-executable files. These files looks very normal, and they are not executable, and you may not, or your antivirus engine may not suspect them, but they have the potential to combine with other system executables. Some of them are known as droppers, and can do something nasty. Then, of course, there are malicious executable files. Then web and email content. Many a times, all of us have experienced that. Phishing. What is phishing? Is basically deriving. Just a moment. Deriving probabilistic model of phishing attack. Then derive probabilistic reputation model for URL. These are some application in intrusion detection, phishing, etc. Now, there are some difficulties in dealing with intrusion. What are the difficulties? That the attackers will always try to hide their action from anybody who they think is monitoring or an intrusion detection system. Typically, how do you know that somebody has intruded in your system or not? You try to look at your system logs. And if you see that at midnight, 3 a.m., somebody logged into your management portal or say ERP system, you know that things are not normal. But what in seasoned bad guy or a seasoned attacker can do, what they will do, they will log into the system, they will do whatever nasty they want, and then they will change the log. They will edit the log, remove all the traces that he has logged in, and reset a modification date on a file. So they can also change the date, timestamp that is given on a file. Okay. There are other difficulties, like there can be undetectable signature based IDS. Okay, as I mentioned earlier, the IDS which are based on signature can have problem because it will have a lead time to create signature and adding to the database, and then the user has to download and update its own database, which is quite some time. And with this today's fast internet spreading and WhatsApp forwards and all email forwards, the damage can be the damage might have already been done by the time the signatures are available. So anomalies can be observed by looking at significant deviation from normal behavior. What is normal behavior? That every day I come to office, log into my email service at 9 a.m. Intermittently within 1 to 2, I am not that active, and again I close it at 6 p.m. That's my normal behavior. Now suddenly, if you see a traffic or email login to my account at 3 a.m., that's an abnormal behavior. So you can use machine learning very easily to detect that. Or suppose normally I log in from 2 devices. One is from my laptop and another is my mobile phone. And the identity of these 2 devices are known. But suddenly you see that there is a third device and the IP address is somewhere in China or some other country, Mexico. So there is a problem. So that is abnormal behavior. So signature and anomaly detection, I think I have talked about in enough of it. Also, there are techniques like using data mining for detection. We can build some predictive model from the normal and intrusive, from the instance that are labeled as normal and intrusive. Okay, and these models can be more sophisticated and this can be more accurate than manually created models. So it can rely on behavior to find out anomaly. But one of the possible problem of this is that high false alarm rate. What is false alarm rate? That on an exceptional day, I was awake a little late at night. For example, last night I was chairing a session of a conference called System Man and Cybernetics, and it was 3 a.m. when the session was happening, and I was awake. So if I'm awake at that time, most likely I'm accessing my emails. And if the system can find it abnormal, and which is a false positive, that means actually, it has been detected positively, but it's not a positive case. Similarly, think about it like I travel to a different time zone, let's say Canada or US. Now, night 3 p.m., 3 a.m. becomes 3 p.m. almost for me. And there can be possible false negatives. What is that? That can't the attacker actually try to launch during my work hours also? They can, right? So if behavior-based mechanism can suffer from those limitations. So there are some standard metrics which are used to benchmark such mechanism. One is called, I just introduced, false positive. So the predicted connection level, there is normal and intrusion. There is true negative, that means it was not an attack and we have detected is not an attack. That is true negative. What is false negative? That means it was an attack, but we didn't realize it was an attack. We didn't detect it. There is a false alarm, or what is called false positive. That means it was not an attack, but we detected as an attack. And then there is correctly detected intrusion detection rate, or is called TP. So based on these parameters, we actually benchmark any detection mechanism. Tomorrow, if you build a detection mechanism, it is very unlikely that we will have a 100% detection mechanism. So your algorithm will be benchmarked by one of these. So there is another parameter called ROC curve when we say area under ROC curve. It represents the trade-off or the difference between detection rate and the false alarm rate. It is basically a plot which is detection rate versus false alarm rate. So an ideal system should have 100% detection rate and 0% false alarm rate, which normally is not feasible. But what we try to do is to maximize the detection rate and minimize the false alarm. These are two big research areas of any security or any information security mechanism using machine learning. Now, machine learning techniques that are used in intrusion detection are like supervised learning and unsupervised learning. Please allow me 30 seconds. I will come back. 30 seconds, please. Sorry. So now the different techniques which are available for intrusion detection system, among the supervised learning mechanism, we have support vector machine. We can use neural network. We can use various probabilistic model like naive-Bayes variation, etc. In unsupervised learning, we can use HMM, various clustering algorithms like k-nearest neighbor, which is distance based, and dimensionality reducing algorithm, etc. There are other techniques like AdaBoost, which will require a little bit of machine learning or like good amount of machine learning knowledge. But just for your information, the mixture of basically, it's kind of in slightly advanced area, and you will require slight, good amount of knowledge. But what I would also like to say that now which one to use? See, all these are not used in end products, and unfortunately, no technique is available to say that okay, for this problem, this is the best mechanism. So what is normally done is that people try various mechanisms. Of course, there are certain rules that or broad-based rules that okay, this kind of problem is there, then this is the better mechanism. But then among that, there are various mechanisms, and we try to choose the best possible mechanism. We talked about malicious JavaScript. Now, one of the way is that you can use naive-Bayes classifiers and used pseudo words, etc., to improve accuracy. You can extract words, and you may not extract all the words, but which are of interest. For example, words like preposition may not help you much, and feed this to a machine learning model, and possibly you get some result. But the life is not that simple. Things are not that easy. JavaScripts these days are highly obfuscated. What is obfuscation? Is that basically making it unreadable. Why do obfuscate? For security reason, for privacy reason, for many reasons, people obfuscate the JavaScript. Let me give you one simple example. If I replace all the character values with their hex values, you know how the hex values are, then we cannot understand what it contains. So it complicates the situation if there are usage of obfuscation by attacker. And these are done by legitimate vendors. Like many times we use a lot of scripts from Google these days, right? These are available as a Web 2.0 library, which is very rich, and we can use them readily. But then they might be obfuscated. And there are many attacks which happens because of this cross-site references. That means you are abc.com, but you are trying to get a JavaScript executed from another website, which is xyz.com. So what, as an attacker, I can do, I can impose myself as xyz.com, and with a DNS, fake DNS or something, and possibly you will execute whatever JavaScript I provide instead of executing it from some other source. Okay, so what are the challenges in ML-based intrusion detection? One is, the first and foremost is the large data size. It is millions of network connections. It has high dimensionality. That means the number of dimension in the data can be hundreds. And then temporal nature of the data. That means the data points are very close. That means they are highly correlated. And sometimes it is very difficult to identify which one is a bad data and which one is a good data. I mean, there might be a case where there is no difference between a bad, an attack or a normal traffic. Okay. I've also mentioned about attacks which are launched using system tools. For example, zip or encryption algorithm or system registry, etc. And then there is a skewed class distribution. That means the interesting events that you are trying to get, they are very rare. That you are monitoring a gigabit network, and you are finding very few worms which are passing through, or very few viruses, or very few attacks that are going on. So to solve that, what we have, we can do data processing. That means changing the data format or doing some pre-processing on the data, and changing it from monitored system to some appropriate system which is suitable for processing. So one of the connotation which people love to give is that finding attacks this way is too little, and the time is also, you have very less time to detect that whether there is a needle or not. Also, high performance computing is one critical aspect for online, scalable, and distributed intrusion detection, and it is costly affair too, because you need those hardwares, and the GPUs which has become very popular. It's not a cheap thing. It costs million. These days the high power one costs about $1 million Indian rupees per GPU, and you might need multiple of them. So there are other techniques that can come handy in this, and very few researchers are working in that area, like MapReduce or Hadoop, where you can use large number of commodity cluster and build a high performance cluster, whereby you can detect attacks. Similarly, inappropriate content detection is another problem. Maybe I will skip through identifying phishing attempts the various techniques that you can use, maybe naive based or SVM based supervised classifier. Mail filter can be trained online using semi-supervised approaches as well. Now I will come to the last part of my lecture, a case study, what we have done, that is detection of fake news on online social network. Simple outline, the problem overview, current solution, limitation of current solution, and our solution followed by conclusion. What is a fake news? It is false or incorrect information. Dr. Shantanu, if can you, or anybody can confirm, like if I'm still audible properly?
Yeah,
Any-
Yes, sir. Yes, sir. You're audible.
Okay. All right. Please feel free to ask any question if you feel like. I know, I am deliberating pretty fast and for quite some time, but yeah, at the end, of course, we can discuss. But at any point of time, if any question is there. What is a fake news? It's basically misinformation, false or incorrect information. What is the purpose? To affect the perception of people. And you will see that during election time, during certain events, there are propaganda machineries, which are funded machineries, and they try to spread fake news. So what is the problem? The problem at hand is to use the large use of social network data, and which became a fertile soil for emergence of rumor or fake news. From the police point of view, they are supposed to, because there are many. Sorry, I think I got disconnected once again. I hope I'm audible again.
Yes.
Okay, thank you. I'm sorry about the network issues. So fake news has the potential, or it can harm real life. So if we look at definitions, it is where individuals or organizations intentionally publish hoaxes, propaganda, or other misinformation. This can include blogs, social media posts, fake online media releases, etc. But what it doesn't include, there are satire news, jokes that are published. So those are not, they are legitimate fact, they look like legitimate factual news, but they are not. Their intention is humor or satire rather than misinformation. Also, fake news doesn't include articles which are written from the perspective of someone's opinion, editorial standpoint, provided the information included is factually correct. Now, what is the intention behind all this? The Rubin et al.'s definition, which is defined in 2015, because this is a recent affair, it checked whose intentionality, what is the creator of the news? Example, governments. Let me give you example of a government fake news. We all heard about when certain countries invaded or the NATO or US invaded Iraq. We heard a lot about weapon of mass destruction. But they could never find, after occupying the country, they could never find weapon of mass destruction. So that was a fake news or fake propaganda by the government machinery. The press, which is actually the purveyor of the news, basically they spread the news. And it can be social media, which can be you, me, or anybody else. So how to capture the intention is a machine learning or data mining feature. That's a challenge. There are many such fake news. One of the recent fake news, like PepsiCo CEO Indra Nooyi told Trump fans that they are going to take their business elsewhere, right? So the Pepsi share tanks. That means Pepsi share falls. Sweden signed a deal to become a NATO member. All that were actually misinformations. And how to detect this misinformation? One is human intervention. By verifying the information veracity, you try to verify it with a known source. Maybe you contact Sweden embassy and try to find out whether really there is something of that sort. But can you do that? Every day, hundreds and thousands of such newses are there. How can you do that with human intervention? The other way is to do it by using algorithm. That means by identifying fake content and validating the information sources. Okay. So what is the current solution? There are linguistic approaches like data representation, deep syntax, semantic analysis, disclosure analysis, classifiers. Most of them are linguistic approaches in the area of machine learning. There are network-based approaches like linked data, that means fact-checking method, and it can leverage an existing body of collective human knowledge and verify that with that knowledge, or query an existing knowledge network. For example, somebody says that Tata Motors stock is selling at 20 rupees, or Tata Motors has acquired a business of some 500 million in Europe. So you can always check that fact with some knowledge base, but that may not be always correct. There were, if you remember, Barack Obama re-election, there were a lot of fake news around it, right? Barack Obama, the one fake news was like Barack Obama is a Muslim, and how it came into the picture with Columbia University and Association of American Universities. Then there were, it was traced, and then a person was found, like, who was responsible for it. So how to actually detect the fake news? One of the way is to read past the headline. Just do not read the headline, but try to read beyond it. Then we can also check who originally published it. If I give a news on my Facebook post, it may not be as credible if CNN gives it or Times of India gives it. But that doesn't mean that there cannot be a fake news on Times of India or CNN. Then we can also follow links and check sources. We can see whatever links and claims that has been given, and we can check their sources. And also we need to look at, and we should be aware about the confirmation bias. There is something, or there is always something which is different. And these days, if all of us are watching news or looking at news, we know that these days we get more views and less of news. So the news reader try to, I mean, irrespective of channels, almost everybody, they try to put their belief in us. What they believe in, they try to influence us that way. That is also a kind of fake news, or they try to reinforce their preconceived ideas. And it's not, I mean, also you assume that there's something which is true because you want it to be. Many a times it is the viewer's fault also. The viewer also wants like something which they want, like always good news, or always bad news about somebody or some organization, etc. So when a channel or a source actually spells out those, it feels nice for those viewers or the consumers. Of course, you can match with other outlets, and if you find an anomaly, and think before you share it. Now, there are fact-checking websites all of us know now, and whenever we get a social media post or a WhatsApp forward, these days most of us try to look at in a fact-checking website rather than forwarding it. So many of these are human strategies, but can we translate these human strategies into machine learning task? It's a busy slide. I don't want to go into it. So what is a formal definition of one of the mechanism what we used in our detection mechanism is stance detection. Let me introduce what is a stance detection. The formal definition says that a headline and a body text, either from same news article or from two different articles, that is the input, and what is the output, that classify the stance of the body relative to the claim that is being made in the headline into one of the four categories. One is agree, that the body text agrees with the headline. Okay. Let me give you one example. That a few years back, I was in US, and I looked at the newspaper, and one of the leading newspaper headline says that, I mean, at that time Pope visited US. It says that Pope asked for women in the hotel. And what actually the body reads the correct news. They say that when Pope visited, he ensured that in his part there should not be any woman. Okay. But you see, they posted the headline in such a way that it can have a different meaning. So agree, disagree, discuss. There are recent headlines like Israel caused flooding in Gaza, where Al Jazeera, Daily Mail has a view, and Jerusalem Post is a view. And then using stance detection, we could find, and also we verified that the claim was false. So how there are various mechanisms. One is automated fact checking, which is by a university in Darmstadt. What they do is they basically create an NLP pipeline, and they take a claim from a user. They look at large corpus in the web, and then they create multiple evidences, and they verify the claim against those evidences, and then they process it and give it a verdict. Another mechanism that is being used is for claim validation is using something called a machine learning technique called LSTM. It's called long short memory. So you get evidence and not an evidence, and you get a sentence representation, and you create word embeddings out of them. And the claim representation is verified against the evidence, and also it is checked with not evidence, and eventually you figure out what the system does. Now, what are the limitations of these systems? First one is quality versus quickness. Many of them gives good result, but they require a lot of time. If I detect after 3-4 hours, then it might be meaningless. By the time it might have spent, it actually operates in retrospective manner. Results in delay between publication and detection of rumor. And what is required is a latency aware rumor detection. So clustering data by using keywords and using some ensemble method we can combine user propagation content, and it can be very, very effective in dealing with such news. Computation of those features are efficient, but what it needs is repeated response by other users. It also results in increased latency between publication and detection. Focus mostly those who are interested in research around these areas, or any of the machine learning based techniques with a relatively large data set. There are several challenges if I say a sentence to school, or I may not go to office, or I say that I may not believe in certain things. Now, that certain things can be a hash.
Hello.
Mechanism will detect my entire post as false. There are other usage of language like emoticons, symbols, etc. All these leads to difficulty in classification. There are some more drawbacks, like most models that are being built are specific to some network, and it identifies only a small percentage of fake data. And that means it requires more feature. There are technical limitations, that how can we detect the signal of misinformation? That means, see, I will see on my Facebook all the posts that my friends are making, or all the posts that my friends have posted. I do not have the entire universal view. I do not have all the tweets that are being circulated today. So we have a limited set of data. And then in such situation, how can we improve accuracy. So the linguistic network-based approach have shown better accuracy in terms of classification task and even in limited domain. There are new tools like refine, evolve, develop, or there are hybrid systems which are good to do that. So what is our solution? What we have done is first we try to solve the technical problem that we do not have data. So we have created a WhatsApp bot. So anybody can actually send data on that WhatsApp number and we get a lot of data. Also, we have created a plugin, a browser plugin. Anybody who installs the browser plugin, we will have, if they agree, we will classify all the contents that are being displayed, all the social media posts or news articles and everything, whatever displayed on that page, we will classify it as like whether hate or false or whatever. And when we do that, we also give the user a privilege that they can send the information back to us. If they send it to us, we get more information. And we have created ML model for text analysis, fake news analysis, image and video analysis, etc. We also look at police database, user report. So actually, Assam Police is also a partner in this, and even some national level, defense organization have shown interest, and they are also or possibly will partner in this work. So we target certain users who are known to spread such or some handles which are known for spreading false news, some hashtags, monitors, tracing old tweets, all of that we do. And we have created Chrome extension, a website, and a chatbot. All these three combined together. What the Chrome extension does, it looks at the chat, it looks at the text, does the chat analysis, it can block offensive words, it can report objectionable content. Also, using the Chrome extension, we can look at the image and do a reverse image search in the background. The user won't have to do anything. And that means any image that is being displayed, we can look at that image. And fake news blocker, we can, as I mentioned earlier, we can warn the user of fake news and we can actually block misleading journalistic sources, etc. Here are some examples. So this is how the text, we get top 20 results of the Google Advanced Search. We compare both the claims using NLP model, and we use softmax layer to generate results. And we also multiply with associated credibility. Over a period of time, we are building credibility. So naturally, newspapers, reputed newspapers will have more credibility than the individual YouTube channel, etc. For images, we do a reverse image search and we also do a morphed image search and then generate the result. The result in web page in floating frames. Basically, on a floating frame, we show that how the result looks like. We have a backend fact checker system, which automatically tells in the WhatsApp chatbot that whether the given text, image, or video is real or fake. So yeah, it has its reporting mechanism, and it can also tell you the viral fake news which is circulating at this moment. So this can be helpful for policing, etc. So here are some of the screenshot from our bot that how does it reply. The technology stack what we have used is React framework, JavaScript, JSON, Bootstrap, and IBM Cloud API. And we have used a lot of REST API, and all machine learning models are used as a API using Flask and backend system. For servers, we have used Amazon EC2 instances, and for WhatsApp bot, we have used Python APIs, Dialogflow, Flask, and Heroku. These are our technology stacks. There are multiple components, and there are a lot of components developed in multiple technologies. We have used a certain state-of-art model. Of course, you require a little bit of machine learning understanding to understand that. With a batch size, we have taken a batch size of 8 and 8 epochs, and a learning rate of 2 to the power 5, and with a dropout ratio of 0.3, and we got an F1 score of around 81.02, which is kind of an 81% accuracy. For file identification, we have used a simple mechanism of MD5 digest. We take MD5 digest of file and create hash value and verify that in the file. So that's all from my side. If you have further question, I sincerely acknowledge the design layout of some slides from Shangun Park et al. And some of the contents from Niti Aayog presentation. Thank you very much for patiently listening for last 2 hours. I'm open to question.
Thank you, sir. Attendees, if you have any questions, please post in the Q&A box.
Friends, it is now the question answer session. So it is requested to you that if you have any questions or you want to know any information, please post it in the chat box or in the question answer section.
I can see one question at least. Yes, PPTs, you will definitely get it. So yeah, you will get it from Dr. Shantanu.
Yeah, and the video content is already available. This entire session is being streamed on YouTube, so you can go to the MAKAUT YouTube channel and you can see the entire video.
Okay.
Any more question? Any more question? So the entire video will be available on YouTube MAKAUT channel, and if you have any more question, you can type.
Hello.
Yeah.
Yes, please.
Okay.
Yeah, I have one question.
Sure.
Can we use ML, machine learning and artificial intelligence to detect an attack before the attack actually happens? Is it possible? Because once the attack happens, the damage is done. So before the attack happens, is it possible?
Very, very interesting and very pertinent question. So once the attack has happened, then what is the, of course, we can be careful next time, but the damage has happened already. All attacks may not be, but there are certain attacks which are very significant attacks. Some of them are known as multi-stage attacks. So in multi-stage attack, what happens that the attack has a whole life cycle. So we can actually model that life cycle, and if we can detect it early, which is feasible, and if we can detect it early, we can spread the we can stop the spread of the attack, and also we can stop the target machine. We can take some appropriate action. We can put some good defensive posture. Yes, it is feasible. Let's say the attack has 10 steps. And now, after first 3 steps, if I have good amount of confidence and say that, okay, this particular set of activities is going towards this attack, I can raise an alarm. Yes, we can. The answer is yes.
Okay, thank you. Okay, Shantanu, you can take over.
Other questions?
I can see one more question.
Okay. Anyone has any other questions?
I answered already, and there is one more question. Is there any software that will process my sentence? There is one more question. Is there any software that will process my sentence or paragraph and it will represent it another way using NLP? There are many Python libraries to do that. I do not know any specific software is there or not, but there are a lot of Python libraries which has these kind of capabilities. Depending on your requirement, what you exactly want to do, you can choose a suitable Python library.
Okay, Hitosh, I know that actually what you have already discussed something that using the banking at night or not, we can detect that whether this type of attack are malicious or not. Is there any other way apart from timing and all these things, so that someone is trying to hack my system and I can get that, analyze those data?
Okay, so again, interesting question. Well, one better way is to look at the network flow. Most likely these days, any attack has to come from network. And the network, again, these days, the posture of the network is different. Earlier, we used to use a gateway-based network. All of us used to share one connectivity, and through the gateway we used to pass through. But in today's world, we have multiple ways of connecting. So the best location to look for such information is in the system itself. So that is why host-based mechanism, or we call it as an endpoint security, has got enormous importance these days. So if we look at from the host perspective, I know what this host is supposed to do. If it is a mail server, it is supposed to send and receive email. And I should not receive any DNS query on this server, because I have never said that this is a DNS server. Or I should not see a SSH request coming from certain individual or certain IP. So we can look at the network flow and figure out from our existing model based on data sets, well-trained model on that whether given traffic or a given flow of traffic is anomalous or not, whether it poses a threat to attack my system or not. So a host-based or endpoint-based security mechanism can really help.
I think we have some more questions. So
let me check. Any specific Python packages? There are a lot. Sudeep, if you want, I have given you my email ID. I will send you a list of packages, but you need to describe your problem a little bit. There is a package called SCIPY, SkyPy. There are a lot of string processing libraries available. Look at those packages. So data mining and pattern matching can be used to minimize the probability of threat. I hope this is a question. Pattern matching, of course, we will have to do a lot of pattern matching. But machine learning is not only about pattern matching. It is about building a model out of the given set of data, right? So beyond pattern matching, and yes, data mining is one technique, but then when we talk about deep learning and neural networks, so we have actually moved ahead of data mining. Data mining is when you have readily available data stored and you mine the data and extract information. So you can find out historical attacks, that whether attack has happened last month or last week or not. But that may not save you from the APTs or advanced persistent threats, whatever we are seeing today. Okay. One more question. Is it possible to identify fake calls immediately asking for bank account related information? Well, the answer is yes and no. You cannot find out because of privacy reason. Why? Because finding out the details about someone else is not a good practice. But in case the law enforcement agencies has a provision, they can ask the telcos for such information. And the form people fill up while getting connection, etc., are available with telcos. And when there is a litigation, the telcos share that information. There is a real-time information sharing mechanism in place.
I think we're again having some connectivity problem.
Yes, sir.
But let us wait for some time.
Further, sir, can you listen us?
Shantanu, can you hear us?
Sir. Yeah, I am hearing. Vito sir is connected,
Vito
but
sir has
not
got connected.
listening us. Yeah, he
Sometime
has logged out.
to reconnect. Yeah, wait for some time for him
Okay,
to.
he's coming back.
Yeah.
If anyone has any questions, you can please put it onto the chat box or in the question answer.
Yes, sir, join.
So I have stopped the screen sharing because that is consuming data and
yeah,
it's connected. So right. Yeah. So answer is both yes or no. If the law enforcement agency wants, and when law enforcement agency will work, when there is a litigation. But from a security researcher point of view, you can trap the way they try to trap you. You can also trap them. A best way is to avoid such calls. And then if you want to know about them, you keep on lingering with them. Then what I typically do that when they say that, okay, send me this information, I ask for their email ID. And spammers or such people's email ID normally are listed. You can search for that email ID. You will know a lot of stories. People will write in Mouthchart or many other places. And then you can, what I also try to do is trick them by sending a transparent image to that mail ID. So they see an email. Maybe they ask for my copy of passport. I send them a fake file which doesn't open, along with a transparent image. The transparent image gets displayed on their email, but they don't realize it is being displayed. And that image is hosted on my server. So I know what is their IP addresses. And from the IP address, I can figure out where their geographic location is. Now, from that information, I can find more, and then I try to target them, like finding more, doing different techniques like OS fingerprinting, social engineering. I try to find more about them, that who they are actually. And many a time you can actually zero in about that user. So yeah, but there is no straightforward way of doing that.
Okay, so we think we have already covered all the questions. There are no more questions over here. Yeah, yep, taken up all the questions. So thank you, Professor Bhavya, for your in-depth presentation on the role of machine learning in information security. You have discussed this topic in detail. You have discussed the different issues, and you have discussed the scopes of further researches. So it was really a great learning experience for all of us. Thank you, sir, for taking time out of your busy schedule, giving us your precious time. You have already been here with us many times in our physical training program. So we hope that you'll be here again with us and you will share with us your valuable knowledge. Thank you, sir.
Sure. It's pleasure meeting you all. Thank you.
Yeah. So now we are at the end of this session. For the attendees, the feedback link has already been shared. Please submit it. And on behalf of the Department of Computer Science and Engineering of this university, we thank you all for being here. And thank you again and for joining us today, and we'll see you